Welcome to Severe Weather Analysis for Lord Howe Island. I'm your host, and if you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Today is Thursday, December 25th, 2025, and we are looking at the morning atmospheric sounding from 10 a.m. local time. We've got an interesting setup developing here. The island is caught between tropical moisture and moderate wind shear, and we are going to walk through exactly what that means for today's weather and what to expect tomorrow. Let's start with this morning's sounding. Looking at the Skew-T diagram, we can see a fairly moist atmosphere with dew points hovering around 21 to 22 degrees at the surface. The temperature profile shows we are starting at 25 degrees and 1/10, with a moderate lapse rate in the middle levels. What's really important here is that there's no cap, no strong inversion holding things down. The mixed layer CAPE is 1052 joules per kilogram, which is solid instability for the Australian environment. The surface-based CAPE is even stronger at 2418 joules per kilogram. Now here's the key. Wind shear in the 0 to 6 kilometer layer sits at 18.7 meters per second. That's moderate shear, enough to organize storms but not extreme. The lifted condensation level, or cloud base, is sitting at 673 meters above ground, which is quite low. That's important because it means any convection that develops will have a shallow warm cloud layer to work with. The mixed layer lifted index is minus 1.9 degrees, indicating instability is present but not dramatic. This is a day where we have the ingredients for organized thunderstorms, but it's conditional on whether anything actually triggers the instability. Now let's look at the afternoon forecast transformation. The enhanced Skew-T shows what happens as the day warms. Notice the heated parcel path, shown in pink on the right side of the diagram. The environment profile, that red temperature line and the green dew point line, they stay exactly the same. We are only heating the parcel, not changing the atmospheric profile, because that's what solar heating does. The heated mixed layer CAPE grows to 1083 joules per kilogram. The surface-based CAPE remains strong at 2418 joules per kilogram. What we are seeing is a scenario where the atmosphere becomes even more unstable with heating. The cloud base actually rises slightly to 695 meters as the air warms and dries a bit at the surface. The wind shear stays constant at 18.7 meters per second. Wind profiles don't change with solar heating. Now look at the threatened parameters. The STP, or significant tornado parameter, comes in at 0.97. That's well below the 2.0 threshold we'd need for tornado potential in Australia. The SCP, significant hail parameter, is 2.19. The SHIP index, which assesses hail growth potential, is 6.28. These values tell us that while we have instability and shear, we are not in a regime where we'd expect severe hail or tornadoes. Instead, we are looking at organized storms capable of producing gusty winds and possibly some small hail. The storm mode analysis suggests supercells, organized rotating storms, but without the extreme parameters needed for the most violent severe weather. Now let's examine the wind profile and hodograph. The hodograph shows the wind vectors at different altitudes color-coded by height. Starting near the surface, that purple section at the bottom, winds are light, coming from the southwest. As we climb, the winds strengthen and back around toward the northwest by mid-levels. In the upper levels, those yellow and green colors, winds are much stronger, coming from the west-northwest. The 0 to 6 kilometer wind shear magnitude is 18.7 meters per second, as we noted. The right mover vector points toward the southeast. That's where supercells moving with the mean wind would travel. The left mover vector points toward the north-northwest. Now here's what matters operationally. The moderate wind shear profile, combined with the low-level wind shift, suggests that any storms developing would be organized supercells with rotation potential. The 0 to 1 kilometer shear is 9.6 meters per second, and the storm relative helicity in that layer is 124 square meters per second squared. That's moderate rotation potential, enough to organize the storm but not in the extreme range. The 0 to 3 kilometer SRH is higher at 198 square meters per second squared. For emergency services, this means if storms develop, they'll be organized and capable of rotating, which should prompt consideration of rotating storm damage potential including rotation-induced wind damage. The hodograph curvature is moderate, not the classic supercell hodograph we'd see in the US. Great Plains, but sufficient for organized convection. The atmospheric refractivity profile, or N profile, tells us about atmospheric stability and downdraft potential. The blue line shows the Bruntweishaler frequency. Higher values mean more stable air, lower values mean weaker stability. Looking at the profile, we see moderate stability in the mid-levels around 3 to 5,000 meters, with yellow shaded regions indicating areas of superfraction, zones where the atmosphere is particularly well mixed. The low-level stability from the surface to about 2,000 meters is relatively weak, which is favorable for strong downdrafts and microbursts. The D-Cape, downdraft convective available potential energy, is 1,041 joules per kilogram, with a downdraft velocity potential of 45.6 meters per second. That's moderate to strong, not extreme, but certainly capable of producing severe microburst winds in excess of 100 kilometers per hour. The evaporative cooling potential is rated as moderate. What this means operationally is that if organized thunderstorms develop, they'll produce significant downdraft wind damage, particularly as precipitation-driven cold air spreads outward from a storm base. The lapse rate in the middle levels is favorable for hail growth, 5.56 degrees per kilometer from 700 to 500 hectopascals, providing a deep layer of supercooled water from the 0-degree level at about 4,300 meters down through the minus 40-degree region. For emergency services, this suggests that organized thunderstorms, if they develop, would be capable of producing damaging microbursts and organizing outflow boundaries that could trigger new convection downwind. Looking ahead to tomorrow morning at midnight UTC, the machine learning model is forecasting a significant weakening of the instability. The Cape completely drops to 0 joules per kilogram. The surface-based Cape also goes to 0. The wind shear actually increases to 101.7 meters per second. That's extreme shear but with essentially no instability. The lifted condensation level rises to 895 meters above ground. The STP drops to 0, and the SCP is negligible at 0.01. This tells us that tomorrow morning will feature a completely stable, non-convective atmosphere. The storm mode is subconvective, meaning there's insufficient energy for thunderstorm development despite the strong winds. Tornado threat is low, hail threat is conditional only if storms somehow initiate, and wind threat is similarly conditional. The model is essentially saying, strong winds tomorrow morning, but no thunderstorms. By tomorrow afternoon at 6 UTC, we see a slight recovery in instability. The Cape ticks up to 0 joules per kilogram, still no convective potential. The surface-based Cape shows a tiny bit of energy at 2 joules per kilogram. The 0 to 6 kilometer shear increases further to 109 meters per second. That's destructive wind shear, but again, with virtually no Cape. The lifted condensation level sits at 893 meters. The STP is near 0 at 0.02, and the SCP is marginal at 0.04. The ship index is nearly flat at 0.03. Like the morning, we are looking at a subconvective regime. The lapse rate from 700 to 500 hectopascals is 4.9 degrees per kilometer, slightly stable. Tornado threat remains low, hail is conditional, and wind is conditional. The overall picture for tomorrow is a day dominated by wind but lacking the convective instability needed for significant thunderstorms. Looking at the parameter evolution plot, we can see the dramatic shift unfolding. The instability evolution shows Cape starting strong at 1,000 joules per kilogram or more, peaking in the evening hours, then collapsing as we move into tomorrow. By midnight tonight, it's essentially 0 and stays suppressed. The convective inhibition plot shows CIN remaining near 0 throughout, no cap to break. The deep layer shear shows a different story. It's relatively steady around 80 to 100 meters per second, with a slight increase as time progresses. The cloud base evolution is fascinating. It starts around 700 meters in the morning, rises to 900 meters by afternoon as the air warms and dries, then drops back down tomorrow as the atmosphere destabilizes. The timing is critical here. Instability is available today through the evening hours, but tomorrow morning and afternoon feature a completely different regime. The Cape collapse we are seeing isn't due to a cap. It's due to the overall destabilization of the atmospheric column as we move away from the tropical moisture source. This evolution tells us that any convective development today needs to happen in the next 18 to 20 hours before the pattern completely switches tomorrow. So here's the bottom line for Lord Howe Island. Today and tonight feature moderate instability with moderate shear, ingredients that support organized supercell thunderstorms if convection initiates. We're not talking about extreme severe weather, but rather organized storms capable of gusty winds, possibly small hail, and strong microbursts. Tomorrow is a completely different story. The atmosphere goes stable and will feature strong winds without convection. Always consult the Bureau of Meteorology for official severe weather warnings and updates. Never use this analysis as your sole source for safety decisions. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia. Thanks for watching, and stay safe.